Welcome back. Let's read some more. It's 11. 11. I just update my reading list. I update all my reading lists. So I had to use a lot of time. Now on page 9. But I'm making some video on my language, Danish. I was supposed to do in English, because nobody understands Danish on YouTube. So I was to do some video, talk about this in English, but now I just do it in my language Danish, or maybe later do it in English. I need half a minute to get to my bed.
Fairchild Semiconductor. Fairchild Semiconductor International, Inc. was an American semiconductor company based in San Jose, California. It was founded in 1957 as a division of Fairchild Camera and Instrument by the traitorous 8 who defected from Shockley Semiconductor Laboratory. It became a pioneer in the manufacturing of transistors and of integrated circuits. Schlumberger bought the firm in 1979 and sold it to National Semiconductor in 1987. Fairchild was spun off as an independent company again in 1997. In September 2016, Fairchild was acquired by ON Semiconductor. The company had locations in the United States at San Jose, California, San Rafael, California, South Portland, Maine, West Jordan, Utah, and Mountain Top, Pennsylvania. Outside the US, it operated locations in Australia, Singapore, Busan, South Korea, Penang, Malaysia, Suzhou, China, and Cebu, Philippines, among others. History, edit. 1950s, edit. In 1955, William Shockley founded Shockley Semiconductor Laboratory, funded by Beckman Instruments in Mountain View, California. His plan was to develop a new type of 4-layer diode that would work faster and have more uses than current transistors. At first he attempted to hire some of his former colleagues from Bell Labs, but none were willing to move to the West Coast or work with Shockley again at that time. Shockley then founded the core of the new company with what he considered the best and brightest graduates coming out of American engineering schools. While Shockley was effective as a recruiter, he was less effective as a manager. A core group of Shockley employees, later known as the Traitorous 8, became unhappy with his management of the company. The 8 men were Julius Blank, Victor Greinick, Gene Huerney, Eugene Kleiner, Jay Last, Gordon Moore, Robert Noyce, and Sheldon Roberts. Looking for funding on their own project, they turned to Sherman Fairchild's Fairchild Camera and Instrument, an eastern U.S. company with considerable military contracts. In 1957 the Fairchild Semiconductor Division was started with plans to make silicon transistors at a time when germanium was still the most common material for semiconductor use. According to Sherman Fairchild, Noyce's impassioned presentation of his vision was the reason Sherman Fairchild had agreed to create the Semiconductor Division for the Traitorous 8. Noyce advocated the use of silicon as substrate since the material costs would consist of sand and a few fine wires. The major cost would be in the manufacturing process. Noyce also expressed his belief that silicon semiconductors would herald the start of disposable appliances that, due to cheap electronic components, would not be repaired but merely discarded when worn out. Their first transistors were of the silicon mesa variety, innovative for their time, but exhibiting relatively poor reliability. Fairchild's first marketed transistor was the 1958 2N697, a Mesa transistor developed by Moore, and it was a success. The first batch of 100 was sold to IBM for $150 apiece in order to build the computer for the B-70 bomber. More were sold to Autonetics to build the guidance system for the Minuteman ballistic missile. At the same time, Gene Huerny developed the planar process, which was a major improvement. Transistors could be made more easily, at a lower cost and with greater performance and reliability. The planar process made most other transistor processes obsolete. One such casualty was Philco's transistor division, whose newly built $40 million plant to make their germanium pad process transistors became non-viable. Within a few years, every other transistor company paralleled or licensed the Fairchild planar process. Huerny's 2N1613 was a major success, with Fairchild licensing the design across the industry. In 1960, Fairchild built a circuit with 4 transistors on a single wafer of silicon, thereby creating the first silicon integrated circuit. Texas Instruments' Jack Kilby had developed an integrated circuit made of germanium on the 12th of September, 1958, and was awarded a U.S. patent. However, Kilby's method was not scalable, and the semiconductor industry adopted Fairchild's process to manufacture integrated circuits. The company grew from 12 to 12,000 employees, and was soon making $130 million a year. 1960s, edit. This section needs additional citations for verification. Please help improve this article by adding citations to reliable sources in this section. Unsourced material may be challenged and removed. January 2017. Learn how and when to remove this message. Fairchild's Noise and Texas Instruments' Kilby had independently invented the integrated circuit, IC, based on bipolar technology. In 1960, Noise invented the planar integrated circuit. The industry preferred Fairchild's invention over Texas Instruments because the transistors in planar ICs were interconnected by a thin film deposit, whereas Texas Instruments' invention required fine wires to connect the individual circuits. Noise's invention was enabled by the planar process developed by Gene Huerny. In turn, Huerny's planar process was inspired by the surface passivation method developed by Mohammed Attallah at Bell Labs in 1957. In the early 1960s, Fairchild R&D began experimenting with the MOSFET, metal oxide semiconductor field effect transistor, also known as the MOS transistor. The first MOSFET was invented by Mohammed Attallah and Dawan Khan at Bell Labs in 1959, and demonstrated in early 1960, but was initially overlooked and ignored by Bell Labs. However, the MOSFET generated significant interest at Fairchild. Inspired by the first MOSFET, Chitang Sa built a MOS-controlled tetrode at Fairchild later that year. MOS devices were later commercialized by Fairchild in 1964, with P-channel devices for logic and switching applications. The experiments led to Fairchild's development of MOS integrated circuits. In 1963, Fairchild hired Robert Widler to design analog operational amplifiers using Fairchild's process. Since Fairchild's processes were optimized for digital circuits, Widler collaborated with process engineer Dave Talbot. The collaboration resulted in 2 revolutionary products, A702 and A709. Hence, Fairchild dominated the analog integrated circuit market, having introduced the first IC operational amplifiers, or op-amps, Bob Widler's A702, in 1964, and A709. In 1968, Fairchild introduced David Fulliger's A741, which became the most popular IC op-amp of all time. By 1965, Fairchild's process improvements had brought low-cost manufacturing to the semiconductor industry, making Fairchild nearly the only profitable semiconductor manufacturer in the United States. Fairchild dominated the market in DTL, op-amps and mainframe computer custom circuits. In 1965, Fairchild opened a semiconductor assembly plant on the Navajo Nation in Shiprock, New Mexico. At its peak, the plant employed over 1,000 Navajos, the majority of whom were women. In the Shiprock dedication commemorative brochure released by the Fairchild Company, the Dime, Navajo, women circuit makers were celebrated as culture workers who produced circuits as part of the reproductive labor of expressing Navajo culture, rather than merely for wages. This claim was based on the opinion that circuits of the electronic chips had a mere resemblance with the complex geometric patterns on the Navajo rugs. Paul Driscoll, the Shiprock plant manager, spoke of the untapped wealth of natural characteristics of the Navajo, the inherent flexibility and dexterity of the Indians. Although highly successful during its operation, the plant was closed in 1975. While the Fairchild Corporation claims the Dine women were chosen to work in the Shiprock plant due to their nimble fingers as previously noted, the women of the Shiprock reservation were actually chosen as the workforce due to a lack of labor rights asserted by the women in addition to cheap, plentiful workers and tax benefits. Fairchild had not done well in the digital integrated circuit market. Their first line of ICS was the micrologic resistor transistor logic, RTL, line, which was used in the Apollo guidance computer. It had the advantage of being extremely simple. Each inverter consisted of just one transistor and two resistors. The logic family had many drawbacks that had made it marginal for commercial purposes, and not well suited for military applications. The logic could only tolerate about 100 millivolts of noise, far too low for comfort. It was a while before Fairchild relied on more robust designs, such as diode transistor logic, DTL, which had much better noise margins. Sales due to Fairchild's semiconductor division had doubled each year, and by the mid-1960s comprised two-thirds of total sales of the parent company. In 1966, Fairchild's sales were second to those of Texas Instruments, followed in third place by Motorola. Noyce was rewarded with the position of corporate vice president and hence became the de facto head of the semiconductor division. However, internal trouble at Fairchild began to surface with a drop in earnings in 1967. There was increasing competition from newer startups. The semiconductor division, situated in Mountain View and Palo Alto, California, was actually managed by executives from COC, New York, who visited the California sites once a year, even though the semiconductor division earned most of the profits of the company. Fairchild's president at that time, John Carter, had used all the profits to fund acquisitions of unprofitable ventures. Noyce's position on Fairchild's executive staff was consistently compromised by Sherman Fairchild's faction. Charles E. Spork was Noyce's operations manager. Spork was reputed to run the tightest operation in the world. Spork, Pierre Lamond and most managers had grown upset and disillusioned with corporate focus on unprofitable ventures at the expense of the semiconductor division. Executives at the semiconductor division were allotted substantially fewer stock options compared to other divisions. In March 1967, Spork was hired away by Peter J. Sprague to National Semiconductor. Spork brought with him 4 other Fairchild personnel. Actually, Lamond had previously assembled a team of Fairchild managers in preparation to defect to Plessey, a British company. Lamond had recruited Spork to be his own boss. When negotiations with Plessey broke down over stock options, Lamond and Spork succumbed to Widlers and Talbots, who were already employed at National Semiconductor, suggestion that they look to National Semiconductor. Widler and Talbot had earlier left Fairchild to join Melectro, which was later acquired by National Semiconductor. In the fall of 1967, Fairchild suffered a loss for the first time since 1958 and announced write-offs of $4 million due to excess capacity, which contributed to a total loss of $7.6 million. Profits had sunk to 50 cents a share, compared to $3 a share the previous year, while the value of the stock dropped in half. In October 1967, the board ordered Carter to sell off all of Fairchild's unprofitable ventures. Carter responded to the order by resigning abruptly. Furthermore, Fairchild's DTL technology was being overtaken by Texas Instruments' faster TTL, transistor logic. While Noyce was considered the natural successor to Carter, the board decided not to promote him. Sherman Fairchild led the board to choose Richard Hodgson. Within a few months Hodgson was replaced by a management committee led by Noyce, while Sherman Fairchild looked for a new CEO other than Noyce. In response, Noyce discreetly planned a new company with Gordon Moore, the head of R&D. They left Fairchild to found Intel in 1968 and were soon joined by Andrew Grove and Leslie L. Verdes, who took with them the revolutionary MOS Silicon Gate technology, SGT, recently created in the Fairchild R&D laboratory by Federico Fagin, who also designed the Fairchild 3708, the world's first commercial MOS integrated circuit using SGT. Fairchild MOS division was slow in understanding the potential of the SGT, which promised not only faster, more reliable, and denser circuits, but also new device types that could enlarge the field of solid-state electronics, for example, CCDs for image sensors, dynamic RAMs, and non-volatile memory devices such as EEPROM and flash memories. Intel took advantage of the SGT for its memory development. Federico Fagin, frustrated, left Fairchild to join Intel in 1970 and designed the first microprocessors using SGT. Among the investors of Intel were Hodgson and 5 of the founding members of Fairchild. Sherman Fairchild hired Lester Hogan, who was the head of Motorola Semiconductor division. Hogan proceeded to hire another 100 managers from Motorola to entirely displace the management of Fairchild. The loss of these iconic executives, coupled with Hogan's displacement of Fairchild managers, demoralized Fairchild and prompted the entire exodus of employees to found new companies. Many of the original founders, otherwise known as the Fairchildren, had left Fairchild in the 1960s to form companies that grew to prominence in the 1970s. Robert Noyce and Gordon Moore were among the last of the original founders to leave, at which point the brain drain of talents that had fueled the growth of the company was complete. A Fairchild advertisement of the time showed a collage of the logos of Silicon Valley with the annotation "We started it all." It was later, in 1971, Don Huefler popularized the name Silicon Valley USA in electronic news. He notes he did not invent the name. See also Gregory Gromuth and TechCrunch 2014 update of Huefler's article. 1970s, edit. Hogan's action to hire from Motorola had Motorola file a lawsuit against Fairchild, which the court then decided in Fairchild's favor in 1973. Judge William Koppel ruled that Fairchild's results were so unimpressive that it was impossible to assess damages under any theory. Hogan was dismissed as president the next year, but remained as vice chairman. In 1973, Fairchild became the first company to produce a commercial charge-coupled device, CCD, following its invention at Bell Labs. Digital image sensors are still produced today at their descendant company, Fairchild Imaging. The CCD had a difficult birth. with the devastating effects on Fairchild of the 1973-75 recession that followed on the 1973 oil crisis. After Intel introduced the 8008 8-bit microprocessor, Fairchild developed the Fairchild F8 8-bit microprocessor, which was, according to the CPU Museum in 1977, the F8 was the world's leading microprocessor in terms of CPU sales. In 1976, the company released the first video game system to use ROM cartridges, the Fairchild Video Entertainment System, or VES, later renamed Channel F, using the F8 microprocessor. The system was successful initially, but quickly lost popularity when the Atari 2600 Video Computer System, or VCS, was released. By the end of the 1970s they had few new products in the pipeline, and increasingly turned to niche markets with their existing product line, notably hardened integrated circuits for military and space applications and isoplanar ECL products used in exotic applications like Cray computers. Fairchild was being operated at a loss, and the bottom line subsisted mostly from licensing of its patents. In 1979, Fairchild Camera and Instrument was purchased by Schlumberger Limited, an oil field services company, for $425 million. At this time, Fairchild's intellectual properties, on which Fairchild had been subsisting, were expiring. 1980s, edit. In 1980, under Schlumberger management, the Fairchild Laboratory for Artificial Intelligence Research, FLAIR, was started within Fairchild Research. In 1985 the lab was separated to form Schlumberger Palo Alto Research, SPA. Fairchild Research developed the Clipper architecture, a 32-bit RISC-like computer architecture, in the 1980s, resulting in the shipping of the C100 chip in 1986. The technology was later sold to Intergraph, its main customer. Schlumberger sold Fairchild to National Semiconductor in 1987 for $200 million. The sale did not include Fairchild's test division, which designed and produced automated test equipment, ET, for the semiconductor manufacturing industry, nor did it include Schlumberger Palo Alto Research. In the early 1980s, Fairchild was one of several Silicon Valley tech companies involved in a lawsuit brought on by residents of San Jose, California. The case pertained to industrial solvent contamination of groundwater and soil in San Jose's Los Paseos neighborhood. A settlement was reached and the area designated a Superfund. Superfund site cleanup ended in 1998. 1990s, edit. In 1997, the reconstituted Fairchild Semiconductor was reborn as an independent company, based in South Portland, Maine, with Kirk Pond as CEO. On the 11th of March, 1997, National Semiconductor Corporation announced the $550 million sale of a reconstituted Fairchild to the management of Fairchild with the backing of Sterling LLC, a unit of Citicorp Venture Capital. Fairchild carried with it what was mostly the Standard Products Group previously segregated by Gillemilio. The Fairchild Semiconductor Corporation announced the 27th of November, 1997, that it would acquire the semiconductor division of the Raytheon Corporation for about $120 million in cash. The acquisition was completed on the 31st of December, 1997. In December 1998, Fairchild announced the acquisition of Samsung's power division, which made power MOSFETs, IGBTs, etc. The deal was finalized in April 1999 for $450 million. To this day, Fairchild remains an important supplier for Samsung. In August 1999, Fairchild Semiconductor again became a publicly traded company on the New York Stock Exchange with the ticker symbol FCS. Fairchild's South Portland, Maine, and Mountain Top, Pennsylvania, locations are the longest continuously operating semiconductor manufacturing facilities in the world, both operating since 1960. 2000s, edit. On the 19th of March, 2001, Fairchild Semiconductor announced that it had completed the acquisition of Ingersoll Corporation's discrete power business for approximately $338 million in cash. The acquisition moved Fairchild into position as the second largest power MOSFET supplier in the world, representing a 20% share of this $3 billion market that grew 40% last year. On the 6th of September, 2001, Fairchild Semiconductor announced the acquisition of Impala Linear Corporation, based in San Jose, California, for approximately $6 million in stock and cash. Impala brought with it expertise in designing analog power management semiconductors for handheld devices like laptops, MP3 players, cell phones, portable test equipment and PDAs. On the 9th of January, 2004, Fairchild Semiconductor CEO Kirk Pond was appointed as a director of the Federal Reserve Bank of Boston, elected by member banks to serve a 3-year term. On the 13th of April, 2005, Fairchild announced appointment of Mark Thompson as CEO of the corporation. Thompson would also be president, chief executive officer and a member of the board of directors of Fairchild Semiconductor International. He originally joined Fairchild as executive vice president, manufacturing and technology group. On the 15th of March, 2006, Fairchild Semiconductor announced that Kirk P. Pond would retire as chairman at the company's annual stockholders meeting on the 3rd of May, 2006. Pond would continue as a member of the company's board of directors. Mark Thompson, then CEO, became chairman. On the 1st of September, 2007, New Jersey-based RF semiconductor supplier Analogix acquired Fairchild Semiconductor's RF design team, located in Tyngsboro, Massachusetts, for $2.4 million. 2010s, edit. In April 2011, Fairchild Semiconductor acquired Transig, a silicon carbide power transistor company originally based in Sweden. On the 18th of November, 2015, ON Semiconductor made an offer to acquire Fairchild Semiconductor for $2.4 billion, or $20 per share, after a few months of speculation that Fairchild was seeking a potential buyer. On the 10th of April, 2016, Fairchild Semiconductor moved its headquarters from San Jose, 3030 Orchard PKWY. To Sunnyvale, 1272 Borregas Avenue. On the 19th of September, 2016, ON Semiconductor and Fairchild Semiconductor jointly announced that ON Semiconductor had completed its announced $2.4 billion cash acquisition of Fairchild. In the fall of 2016, the Fairchild ON Semiconductor International closed the West Jordan, Utah, manufacturing plant. Landmark status, edit. On the 8th of May, 1991, the State Historic Preservation Office designated the site of invention of the first commercially practicable integrated circuit as a California Historical Landmark #1000. A description on the commemorative plaque reads, at this site in 1959, Dr. Robert Noyce of Fairchild Semiconductor Corporation invented the first integrated circuit that could be produced commercially. Based on planar technology, an earlier Fairchild breakthrough, Noyce's invention consisted of a complete electronic circuit inside a small silicon chip. His innovation helped revolutionize Silicon Valley's semiconductor electronics industry, and brought profound change to the lives of people everywhere. Alumni, edit. 1 Gil Amelio. 2 Julius Blanc. 3 Lee Boycel. 4 Ron Brackman. 5 Wilfred Corrigan. 6 Alan L. Davis. 7 Richard O. Duda. 8 James Thermurley. 9 Kirk Ennis. 10 Federico Fagin. 11 Jack Gifford. 12 Victor Greinick. 13 Andrew Grove. 14 Peter E. Hart. 15 Gene Huerny. 16 Lester Hogan.